Hello everyone, welcome back. Today we will be diving into some pretty important derivatives, right? The derivatives of trig functions, so sine of x, cosine of x, tan of x, and their reciprocals. Let's jump straight into this. Okay. So we have the derivative of sine of x. This is a pretty fundamental rule here. Derivative of sine of x is going to be cosine of x, right? And the derivative of cosine of x is going to be negative sine of x. Right? I'm going to dive into the intuition behind why this is true in a separate video, but for now, just accept it as a rule because we will be using it to define pretty much all of the other trig functions, derivatives of the other trig functions. Okay, so let's move on. Right now, what about the derivative of tan of x? Well, you can rewrite tan of x to be sine of x over cos of x, right? I'm sure you remember this, right? And if we were to take the derivative of sine of x over cos of x, you would be using the quotient rule here, the quotient rule, right? Which would give you, if we were to take the derivative of sine of x here, we would get cosine of x times cos of x right here, cos of x, right? Minus, you remember that, right? Sine of x times the derivative of cosine of x right here, which as we previously established is negative sine of x, okay? All of this over, that is a very messy line, all of this over cos squared of x, right? So then if we simplify this out, you can probably see what's happening, right? We have cos squared of x plus sine squared of x. This is your Pythagorean identity. This is equal to 1 right here, right? This is equal to 1. Okay, so this is going to simplify to 1 over cos squared of x, which is going to be equal to secant squared of x, right? That's your final answer for the derivative of tan of x here. What about the derivative of maybe, I don't know, let's do secant of x. Why not? We just mentioned it, right? So secant of x is going to be 1 over cos of x, right? Right, and if we were to take the derivative of 1 over cos of x, we could use the same thing, or we could also use the product rule, but I'll use the quotient rule here, right? This would be equal to derivative of 1, right, is going to be 0 because 1 does not change with respect to x here. It's just a constant, right, times cos of x. This is going to be 0 anyways, but I'm going to write it anyways, times 1 times the derivative of cos of x here, right, is going to be negative sine of x over cos squared of x, which is going to be equal to, right, this cancels out because of the 0 here, right, this cancels out, which is going to be sine of x over cos squared of x, which you could write as tangent of x, right, sine of x over cos of x, times 1 over cos of x, or secant of x. So the derivative of secant of x is going to be tan of x times secant of x. Okay? All right, let's try the derivative of cosecant of x right now. Okay? Derivative of cosecant of x, that would be, we could rewrite this as 1 over sine of x, right? You can see where this is going. We'll use the quotient rule again, right? Take the derivative. We'll go a little faster this time. Okay? So this would become equal to 0 times sine of x, right? And this is going to cancel out in the end anyways, right? Minus 1 times cosine of x, right? Derivative of sine of x is going to be cosine of x. All of that over sine squared of x, right? Okay. And this is equal to negative cosine of x over sine of x, sine squared of x, sorry, right? And you can rewrite this as negative cotangent of x, cosine of x over sine of x times cosecant of x, right? And this would be your final derivative here. All right, let's do one example here, one more example. Let's do the derivative of cotangent of x, right? I think I'm going to save the inverse functions for another video, right? But let's worry about this for now. So you can rewrite cotangent of x as cos of x over sine of x, right? Cos of x over sine of x. You bring this over, we're taking the derivative of cosine of x over sine of x. So cosine of x over sine of x. Once again, using the quotient rule, right? So the derivative of cosine of x is going to be negative sine of x times sine of x from the denominator here, minus cosine of x, that just exists here, times the derivative of sine of x here, which is also going to be cosine of x. All of that over sine squared of x, right? And we can simplify this further to negative sine squared of x minus cosine squared of x over sine squared of x. By now you probably can see how this is similar to tangent, right? Derivative of tangent of x, right? We can factor out the negative 1 from the numerator to get sine of x, sine squared of x, plus cos squared of x, right? And this is going to be equal, to 1, right? Pythagorean identity, right? All of this over sine squared of x, okay? Which is equal to 1 over sine squared of x, which is also equal to negative cosecant squared of x. Yeah, that's the derivative of cotangent, negative cosecant squared of x.